Hello. Another mystery of our time is an elementary particle. For example, photon. What do we know about it? Physicists say that light has particle and wave properties. Why? Because they see wave-like patterns in experiments' results. Photon is something that leads to appearance of a pattern that looks something like this. But what is photon in reality? Let's investigate. Its energy is described by the formula E equals reduced Planck's constant multiplied by W, where W is angular frequency. This frequency is somehow connected with the oscillation of some wave. I will not try to explain it to you as we will give it another meaning. Einstein explained us that E equals mc squared. Mass and energy are different names of the same entity. Mass is a quantity of matter, so energy should be a quantity of matter too. So in our original formula we have quantity of matter on the left side, and on the right side we have reduced Planck's constant multiplied by some angular frequency. Reduced Planck's constant is constant, so angular frequency should appear to be a quantity of matter too. Why we say that it's not quantity of matter, but some frequency? Logic tells us that we should at least try to find a model in which W is a quantity of matter too. Another interesting thing is that action is discrete in quantum physics. Action has units of energy multiplied by time. So we multiply energy by time and we can get 1 reduced Planck's constant of action, 2 reduced Planck's constants of action, 3 reduced Planck's constants of action, and so on. Why is it discrete? Let's assume that action is discrete because time is discrete and energy is discrete. If we sum up or multiply discrete amounts of something, we always get discrete result. For example, we can sum up or multiply apples using natural numbers. The result will always be natural amount of apples. 1 apple, 2 apples, 3 apples, etc. The same way for action. If energy is discrete and time is discrete, we can get 1 action, 2 actions, 3 actions, 4 actions, 5 actions, 6 actions, and so on. In the previous video I assumed that our universe is a huge discrete robot. You can see the details and additional links in that video. Link to the video is in the upper right corner of the screen right now. So what if all our particles are discrete robots that consist of discrete pieces and each piece has energy that equals reduced Planck's constant? In this case, reduced Planck's constant would be not only quantum of action, but also quantum of energy of a particle. We cannot prove that elementary particle is a robot, but we can investigate consequences of such assumption. Let's return to our original formula, E equals reduced Planck's constant multiplied by W. In this case W is not frequency, but the quantity of matter, the exact amount of discrete pieces in the particle. And if that was true, it would be really huge amount of pieces. If my calculations are right, it would be 3.77 multiplied by 10 to the power of 15 for photon that represents color between green and blue, 1.4 multiplied by 10 to the power of 24 for proton at rest. Yes, these are really huge numbers and it might be hard to believe that nature can work like that. But existing models assume that instead of consisting of billions of pieces, elementary particle somehow stores the amount of energy it's responsible for. Somehow stores its mass, momentum, direction of movement. How exactly would it do that? How would photon store its polarization? Answering these questions might appear to be more complex than assuming that all these properties just emerge from the combination of pieces that photon consists of. In my previous video that demystifies the Schrödinger cat and Lorentz transformations, I've shown a sequence of coins that describes mutually exclusive movement on a checkerboard. Assumption that we live in a world that consists of mutually exclusive events would explain the Schrödinger cat mystery, explain Lorentz transformations and other stuff. You can see details in that video. Link to the video is in the upper right corner of the screen right now. So let's copy that algorithm and use it for our particle. Let's assume that every discrete piece of a particle represents a direction in space. These directions should represent mutually exclusive movement events, so they can be arranged only along one axis or along perpendicular ones and have equal length. In any other situation, movement events will not be mutually exclusive. Because if axes are not perpendicular, movement along one axis will also cause movement along another axis. For example, let's assume that we live in a flat two-dimensional world, which has axes with angles 60 degrees between them. In such world, after moving distance d along first axis and moving distance d along third axis, you will appear to have moved distance d along second axis, which you did not mean to do. If movement events have different length, they will not be able to cancel each other, so will not be mutually exclusive either. So if we want to get mutually exclusive movement events, their directions can be only perpendicular in our 3D space and have equal absolute length. We can call those directions left, right, up, down, forward, back. Let's start with only two perpendicular directions for simplicity, right and up. Imagine that you decide where to move next using instructions that look like a sequence of coins, which can be either heads or tails. If it's heads, you move right. If it's tails, you move up. After following the instruction, coin is moved to the bottom of the sequence and the next instruction is followed. So all coins are used as instruction one by one in infinite loop. Each movement we will call a moment of time. Let's investigate how such discrete machine would behave depending on the amount of pieces in it. If it has only one piece, it could be heads and particle would move right, or tails and particle would move up. If it had two pieces, it could be two heads and particle would move right, two tails and particle would move up, or it could be one heads and one tails, or one tails and one heads and particle would move diagonally. The same way for three pieces we have four possible directions, for four pieces we have five possible directions, etc. As you can see, the more coins we have in particle, the more directions we can move in, and the higher is the frequency of possible directions of movement. So we replaced frequency with quantity of matter, and now we got the frequency back. So maybe we found the reason for the frequency existence? Now I will show you how we can get wave patterns and even interference in discrete space. We will use discrete computer monitor as an example. Our monitors are discrete and consist of pixels. Some amount of pixels for x-axis and some amount of pixels for y-axis. When we draw a line on discrete monitor, we can get into situation when line should be drawn between two existing pixels. In this case, anti-aliasing is used. The nearby pixels are partially filled with required color. It looks okay when line's frequency is low, but leads to appearance of wave patterns that you can see on the screen now when line frequency is high. As you can see, wave frequency grows as line's frequency grows. Everything is similar to wave behavior of a particle. You can even see a pattern similar to interference if we use two sources of lines. This behavior have much common with the wave behavior that we see when laser passes through a slit or through two slits. This proves that interference or diffraction in principle can exist in a discrete world. So we can try to find the rules of such world and compare with the world we live in. In next videos I will try to show you what would wavelength, de Broglie wavelength, red shift, blue shift mean in such discrete world. Also I will explain Heisenberg uncertainty principle, observer effect and much more, including Bell's inequalities. Now I will show you how the particle we created produces a wave behavior. Imagine that we have several particles constructed the way described in this video, but with four possible directions: up, down, left, right. We give equal initial state to all the particles, all of them get 20 directions up. And after that we add 5 particles with random direction to each of the created particles. What do we get as result? We get limited amount of possible movement directions for each particle. The particle's behavior creates patterns that looks much like what we could call wave. If physicists saw this pattern in experiment, what would he say about it? He would say that these particles have wave properties. Just as he says about light now. Of course I did not explain everything is so huge. But in my honest opinion we've got a good starting point. We made a very simple assumption, and together with other videos we got wave behavior, explained Schrödinger cat, Lorentz transformations, time dilation. Also I've shown a prediction that could prove or disprove the existence of absolute frame of reference and absolute time in fixed special relativity. Link to the video is in the upper right corner of the screen right now. What if you are looking at the real structure of the universe? Who knows how far we could go? Subscribe to this channel and we will find out. Also I would like to explain why I don't publish all of this as a paper in scientific journal. Any scientist would do that. Well, for the first, papers are suitable for writing math formulas, but algorithms don't work on paper. For the second, the real science is not ready for these ideas yet. In short, they look at it some crazy stuff. Quantum whoa, as they say. For the third, there is no such science as algorithms of universe. As a result, there is no corresponding scientific journal. And finally, I'm not scientist, I'm a programmer. Programmers don't like papers, they like startups. Imagine how huge could be the startup that uses the algorithm of universe. And what it could try to build. Quantum computers could look like a joke comparing to that. I can't say that I have algorithm of universe yet. But that's the way progress works. We get something simple and then we develop it. Yes, these ideas are simple, even primitive, and I believe that's a good idea for how universe could appear. It could be something really simple and then it could evolve to what we see now. Einstein once said that God does not play dice. Well, because I assumed that there are only 6 possible directions of movement and each quantum of energy points in one of those 6 directions, we can poetically say that per this theory, God was a dice himself. I should mention that it is not kind of God that you can pray or ask for something. It's simple and primitive, so it can't help you. It's just the initial state of universe. Something that world could evolve from. The common ancestor of all matter. The discrete machine that together with his copies literally constructed us through evolution. Thank you for your attention.